Hello, everyone, and welcome back to your session of probability and statistics. As I mentioned today in statistics, we are going to look at the bootstrap. So the bootstrap method, as I mentioned before, suppose you have data points, so your sample is small. You cannot make large sample because it's so expensive or destructive or what have you. And now you want to construct a confidence interval for that sample or for the population from which that sample came from. The problem, of course, is that you cannot use the z, you cannot use the t, you cannot do anything because the central limit theorem doesn't work, right? So if they are coming from an exponential distribution, let's say, or any other distribution not normal or not at least symmetric like the normal, how can you construct such confidence interval? So statisticians came up with this idea, which is called the, the bootstrap method. So really the sample is our population. And you say, okay, if the sample is our population, that's limited. No, we are going to make it infinite population. And how do we do that? See what we are going to model. First, we'll talk about the idea and then we see how we model that. So so if say, just for simplicity, because we cannot, just to save time, I'm going to tell you, suppose I have a sample of size 3. Of course, we can't work with 3, but let's just to give you an idea. And these numbers inside the sample are 5, 8, and 12. I assume I have infinitely many 5s, infinitely many 8s, and infinitely many 12s. And then I'm going to select samples from that population. Of course, we would have to have at least like 20 data points to make sense, right? So we assume we have 20 data points, but I have infinitely many of each of them. So we'll see how we model that. And then I'm going to select a sample from that infinite population, okay, and save whatever I want. I want to construct a confidence interval for the mean, so I'm going to store the mean of these samples. And then I'm going to find, if I want a 90th percent, 90% confidence interval, then I would look at the fifth percentile and the 95th percentile, and that's how simple it is. So let's see how we do that. First, we are going to use, let me clear, oops. We have a file called cap, and this file has like data from 2 machines, and it calculates the torque applied to each machine for some reason. We are not here to discuss that. So suppose I want to take one of the 2 machines, either machine 1 or machine 2, and look at the torque and construct a confidence interval for the mean value of the torque or the median. We never learned how to find a confidence interval for the median. So how can we find a confidence interval for the median, for the standard deviation, for any parameter of that distribution? So first, I'm going to read the value, see how it's a large file, not large, it has like, I think 68 data points. Like pretty much half of them machine 1 and half of them machine 2. And you would say, so that's more than 30, right? So I can use the confidence, like the central limit theorem and find confidence interval. Yes, you can, but we will assume we only have 20. I will pick one machine at random and assume I'm going to take the first 20 data points there. So they are not 30. Okay, that's all what you have. So let's see how we do that first. I'm going to say, for example, my data equals, it's a text file, so I'm going to say read.table. The name of the file is cap.txt, and it has headers. So I'm going to say t, or headers equals t. And that's all. Now, let's run these so you can see the data. You see, 68 observations. Of course, you can say view my data, or simply click on it and it will show you that. So you have some torques here and the corresponding machine. So they're different and pretty much 30 something, like, half of 38, 68 is 34. So around 34 of each, maybe slightly more, slightly less, which is more than 30. So we'll see how we can do that. So now I can go back and say, by the way, you can say attach my data and you don't need to use the dollar sign, or simply say my data. Now I'm going to take a subset of it, equals subset of it, of my data. And then you have to give the condition. So we have to pick one of the two machines. So let's say uh, my data dollar sign machine. Let's say we pick the second machine, equals 2. Notice we have to write it as double equal because that's, oh, subset. Oh, I'm sorry. I use the same my data. You have to say where are you getting the data, and then you enter um, the condition. So I get 32 observations. Okay. The 32 observations have two things, torque and machine. I don't need the machine, right? Because the machine I know it's already number 2. So we want to delete that. Just keep the torque. So I'm going to say my data. That's an easy one. We can say equals my data dollar sign torque. So now it's just going to give me 32 data points of just torques. Okay. Then I'm going to say my data equals my data from 1 to 20. So now I only have 20 data points. And you can see that you can say here, view my data again. Since I cannot click on that, view my data. And you can see it tells you there are integer values and there are 20 of them. And these are the first few. Okay. So we know that we only have now data for the torques. Now, let's come here and say, I want to, oh, it's frozen. I don't know why it does that. Sometimes you have to go back and forth a few times. I still didn't understand how to fix that. It doesn't do that all the time, but when it does, okay, now it works. Suppose I want to construct a 90% confidence interval for the mean, mu, a 99% confidence interval for the median. The median is mu, usually we use tilde above it, and a 95% confidence interval for the variance or the standard deviation, sigma. Notice, I didn't know how to do that. I can't use Z or T. I can't use chi-square for the variance and then take the square root. So how do I do it there? We are going to create a matrix with 3 columns where I'm going to store mu here, mu tilde here, and sigma there. And we learn how to do that, right? We are going to run the simulation. So we'll have how many replicates? I usually use 10,000. I don't know why, but it doesn't matter. We can pick more. So let's see how we can do that. First of all, I would set n, which is the number of replicates, n equals 10,000. And then maybe small n or m for the sample size. They are 20. So I can say 20, or it's better to say length of my data. Okay? So now, and still I need to create um, a matrix to store that, to store these values. So I'm going to call it boot since it's a bootstrap. I mean, you don't have, you can call it X, you can call it Z, you can call it whatever. But I prefer to call it boot and say boot is a matrix. Last time we said 0, so this time we say NA. It doesn't have any data. It has uppercase N rows and 3 columns. I have to enter 3 because I want to store the mean, the median, and the standard deviation. Okay, so far so good. What else do I need? Oh, I'm sorry. I said, yeah. Now I want to run a for loop. So for, maybe we say a counter or count in 1, or you can call it n because I just used n. And I don't want to confuse the letters, so I'm going to use a name, a counter, okay? So for count in 1 through n, opens braces, go to the next line so you can't forget to close it. Okay. I by the way, magnified the text in all our exercises so you can see the screen better. But of course, the drawback is that you won't be able to see the whole programming or the whole. So maybe, okay, we can always make that small. Okay, so what am I going to do? I'm going to create a sample of size m, meaning 20 data points, from an infinite solution of infinite sample of the numbers I showed you, right? The numbers stored in my data, the 20 data points. So how do we do that? Uh, we can say, for example, x, we say sample from where? From my data. How many data points? M, meaning 20, but they are 20. So they are going to collect the same data every time. I won't have any variability, right? Doesn't make sense. No. Here, replace is false. If I make that replace, I don't need to type it. I can say true right away. If replace equals true, you can write the whole thing or just T. Then every time it selects a data point, after adding it to X, it would return it and pick again. So it may select the same data point more than once. So this is the same as selecting the data from an infinite streams of these 20 data points. And that's how we model that, how we trick the software into believing that these 20 values, they're not 20, they're infinite, but the population only contains these 20 things. Okay, so it's picking from 20 items only. Okay, so once we do that, how we are going to store the values? Okay, so I can say boot of I. Notice here I have boot has two parameters because it has a row and a column. So I want to say the boot I, if I say I, it means the whole row, but I have 3 columns. So I have to say IN1 equals the mean of X, right? Oh, I'm sorry, I wrote I, it should be count. Count. Boot of count and 1, I will store the mean. And boot of count and 2, I'm going to store the median. And, and boot of count and 3, I will store the standard deviation. So we solved the second problem, is that we are going to generate 10,000 rows. In row 1, in column 1, I'm going to store the mean. In column 2, I'm going to store the median. In column 3, I'm going to store the standard deviation. So now I will have 10,000 of each. I want to construct a 90% confidence interval on the mean. So in column 1, I want to take the 5th percentile and the 95th percentile, or yeah, 5%, which is 0.05 for the mean. For the median, I want 0.5% and 99.5%. So the difference would be 99, median. And here I want the 2.5 percentile and the 97.5 percentile. The difference is 95 for sigma. Okay, so how do we do that? The keyword, the magic word in RStudio is called quantile. It's not percentile, it's called quantile. So you'd say, oh, we have 4 of them, quantiles. No, quantile is a keyword that gives you, so if I want this, I would say quantile 0.025. It will give me the 2.5 percentile. Okay, so it's a percentile, not a quantile, but they call it quantile. So once the simulation is done, I can say, notice I'm not going to waste your time creating, like writing that in a file and write it in a format. No, I'm just going to give you the numbers. So how do we do that? So we can say, um, I can just print them. I'm not going to even call them, I can call them. So I can say mu lower equals quantile of boot. And now I want to say the first column, but how do I enter the rows? I want all of them. So should I write from 1 to 10,000? No, you leave it blank. Leave it blank, meaning take all of, I'm sorry, take the first, yeah, take all the rows and first column and give me the 5th percentile, 0.05. If I want mu upper, I would do the same thing. Okay, I would do the same thing and change that into 95. And then if I want the median lower, let's copy those. Okay, paste them again. So for this, I will make it median. I wanted the 99th percentile, so I make that 0.005, and I make that median upper 995. And then this is standard deviation. Oh, and these are twos. That's the second column, and that's the third column. I want this to be 0.025 and 0.975, and this is SD lower, SD upper. Hopefully, we won't get errors. I don't know if I did everything correct. Yeah, hopefully we didn't get errors. And you can see here, oops, I never printed them out. Oh my God. See, I said that must be something wrong. So I really don't need, I don't need that. I will see that the first 2 are for the mean, the second couple is for the median, and the last would be for the standard deviation. As I said, you can always say cat and then the the 95% confidence interval on the mean equals, and then you do the brackets like we did before. It's just a waste of time now, since you know how to do that. Okay, so it's telling you the 95%, the 90th percent confidence interval on the mean is lower 2415, upper 2885. For the median, it's 21 and 32. And for the standard deviation is 5 through 7.6. Very simple, right? You see, so now that's the key of using the Bootstrap. The data is in front of you. Yeah, we typed a lot, but most of it was like, for example, these 3 lines are copied and pasted. These 6 lines, we write the first one and copy and paste, and so on and so forth. So it wasn't really bad. We read the file. We learned how to pick specific values from a file by, excuse me, by using the subset or by using the $sign to pick only one column that we are interested in, and how we pick like 20 points out of 32. So I did it on several steps, and you can see that it should be very easy. I think I will stop here with RStudio for the time being, and then go back and start. The thing that we left before was the confidence interval for the population proportion for one population, or the difference of two if there are two populations. Again, we'll be using the Z statistic. It's pretty straightforward. Notice that the proportions come from the binomial distribution, but the Z is for the normal distribution. But when the binomial distribution is very large, and because we can approximate it by the normal, like we did, for others. And even though this is discrete, this is continuous, but it's very easy to do it. Okay, thanks for your time. Hope to see you again. Have a great day.